check. Good. Okay, cool. This is my code for my lane detection algorithm. I'm gonna run through the code structurally really quickly, and then after that I'm gonna show you the videos. So this is the while true, so our main function. I don't know why I used while true. I think I was using an old piece of code from one of the other homeworks, and I had a similar syntax, so I just ended up using this. At the start, we define our video, we pull the video out, we read it once to put these variables that are quote-unquote global variables. I would say global in Java, but this is Python, and those keywords are less necessary. So w is equal to round frame.shape1, which gives you the width, and then height is this. Then I made this small, tiny little switching sequence. If it is any of the videos from these examples, it's given these values, and if not, it'll print out the video name so that I know what I'm doing is, or the video I'm playing is wrong, or at least not part of the class. The first function I defined was actually made later on, but I put it up here because I was working on it for some reason. What this does is it creates 4 rectangles that kind of box out the frame, so that only the front of the car is visible to the lane detection algorithm. These are not necessary. Sorry. Are these incasted? Yeah. Okay. Sorry about that. Here the mask function is working, which is really similar to the one that Dr. Mitchell used, except instead of putting the values, here, I put them up here so I can edit them more easily. This is lineIt, which is a function that takes rows and thetas and obviously gives you the x0, y0, x1, y1, x2, y2. These are smoothness variables. I use these because for 30.mp4, which is what I was training or testing my algorithm on, the right side keeps just blinking and then shutting off. So to avoid that, in most cases what I've done is I've saved the x1, y1, x2, y2s here so that, hey, if you don't see it for a couple frames, you can use these. You know what I mean? If for 2 or 3 frames the functionality remains that it'll continue to use these, it'll continue to save these, the previous file, so it'll just stick there. Combine halves. Instead of stopping the lines, I thought of doing it a different way. I thought of actually getting the original frame and gluing it back on, so it's more like there's a photo in the back with the X's, and I've pasted on the top of the original photo, and that's done here. This I found in this one Stack Exchange post, and I figured out how to use it. So it's the first top part is the original frame, then there's the middle, which is our annotated frame, which has our lines on it, and then bottom is original frame, so we can get the hood of the car, so you don't have to have the lines overlapping over the hood of the car. Median line takes our list of thing, a list of pairs, rows and thetas, and then it finds the medians and then returns those. Only if row and theta are not nan, which happens when you get an array, or when you don't pick up any lines from the offline, so you get a list of zeros. That's what this is, to catch that case. Now for the main. So the first thing we get is this video. Too early in the game did I show you the final one. But that's fine. You know what? I'm gonna do the thing where I just go through and each time I'll just add a video. So we've shown the original video. Now we're gonna show the original video and the mask. I don't know if you can see the original. Oh, I guess not. Oh, because it's 2 different frames. Okay, sorry. Yeah, I have 2 different frames. One is the combined frame at the end, and one is the original frame that we do all of this masking to. Okay, cool. Then after that, we use thresholds to make it black and white. You create a binary, and on this, you're going to do our edge detection and our Gaussian blur so that we can better detect these long lines. You do Gaussian blur, then you do your edge detection, which is a candy. Then you use the chop, which is taking the rectangles off the sides and the bottom. So if we're looking at candy originally, actually, I want to show you this. You you're looking at something like this, which we're familiar with. You know, this is something we've seen. But now what I'm doing is I'm taking this and I'm chopping off the sides and the top and the bottom so that we just get the lane in front of us, just the lane, just the road in front of us, without, you know, the cars, not the cars on the side, you can still see the cars, but without the borders and without the trees and without all the other lines. So it really simplified the process of kind of troubleshooting. Then we do our half lines. We get a list of lines. We create our left and our right arrays, which we are going to populate by checking if A, are they at a certain angle. You know, I don't want them to be fully vertical or fully horizontal. And dealing with those was just too much of a headache, so I was like, okay, let's make sure it's within some range of 45 degrees, because that's approximately where our lines want to be. Then we check if y1 is greater than y2, and that gives us the information of if that's true, then it's on the left side because the line's being drawn this way, and if that's not true, then it's on the right side because the line's being drawn this way. All right, awesome. If right is greater than 0, if left is greater than 0, obviously plot your new lines that you just got. If not, plot the old lines from this smoothness variable, or these variables that or the lists, the smoothness lists that I had saved to not make it look, you know, super terrible. Okay, now I'm gonna run our final video. And it spots out at the start because it's super bright, but you can see on the right it's kind of updating more slowly than the left, and that's because it's a little bit sleepy. It's using that old variable more. But in some of the other ones, you see that if it doesn't find anything for a really long time, then it kind of loses it. But there's still a little spots of value that are missing. Those are kind of difficult. I've been trying to tweak them, but a lot of these values are super similar in terms of HSV. And I'm not entirely sure what to do to affect those. I have just now been testing out the Gaussian blur and editing those, so if I get that, if I figure that out, then I will add that video to the end of this video, which is explaining where I'm currently at 10:17 on April 4th. I have been working on this video for a while, or on this homework for a while, so I mean, I don't want to give up, but I am getting exhausted, and I do have to go get dinner. Here's the second one. Works pretty well. The left one does get slow down as compared to the right one. You can see it, and this happens. It does lose itself in the orange, but overall, it's not super bad. Yeah, it keeps blinking in and out. And that's just because of those weird values that come up from time to time. It is still within 45 degrees of distance. This one loses the most. I think we completely lose the right side. Yeah, right there. It completely leaves because the border and this are the same value. I've been trying. I clicked on them. The HSV value is the exact same, and then over here we also lose it because of this shadow in the bottom left that interrupts these lines in our window. So this is kind of the part where it freaks out a little bit. The values are not really making sense, and unfortunately that's the last one. I also have used really specific values here, so what I'm going to do to illustrate maybe a more general performance of that, or maybe even a better one, is I'm going to try to use these values, because I was trying to get very, very specific, but I think that's kind of pushing me in a worse direction. So here, I don't think the lines are ever going to cut out, but we are going to lose it a lot more to that right side border because of the brightness, because that it has a really similar contrast in the video to our bottom lanes, and this left one is completely lost to the shadow, but at least they're both on the screen still. We're not really losing them as much. Yeah, it dies. That's the one that's been the most challenging for me. I've been working on this for a long time. I think that I completed, a lane detection algorithm in the context of all of these. So that's my video. Thank you.